Now we're going to prove the factor theorem, and before we do the proof we have to be clear on the meaning of a root. In this question we're talking about x equals k, which is a root of the function fx. Now a root means, if k is a root, it means that k subs in and we get 0. So just to be clear on that, what we mean by a root is if x is k is a root, well then if you get f of k, this will evaluate to 0. So we can now start the proof by writing down what fx is. Fx is ax cubed plus bx squared plus cx plus d, and then fk. And fk is just a matter of subbing in k for x, so you get a k cubed plus bk squared plus c times k plus d. And in the next step we subtract. You get fx minus fk. And we can do this quickly by subtracting in columns. So subtract these columns first. It's ax cubed minus ak cubed, and we can take out the a all in one step. A is common, so we get a into x cubed minus k cubed. And do the same with this column here. Subtract and take out the b's at the one time, so we get b into x squared minus k squared. And again, take out the c and subtract in one step, c into x minus k. And d minus d cancel, so the d's are gone. Now, bearing in mind what I said earlier, if x equals k is a root, so this is a root, x equals k, that means that fk must be 0. If we sub in k, we'll get 0. So this term now becomes 0, fk, so we were left with fx on the left hand side. And we can also factorize further on the right hand side. A into, there's a formula for x cubed minus k cubed. It's not in the table, so you're going to have to learn this formula. It's x minus k into x squared plus kx plus k squared. We'll do the same here. B into x squared minus k squared is the difference of two squares, so it's x plus k by x minus k. And finally we have c into x minus k. Now the last step is to just inspect the terms here in fx. So this is all fx now on the left hand side, and if we look here we see that we've got x minus k here, we've got x minus k here, and x minus k. So we've got x minus k in each term. This means if we divide both sides by x minus k, the x minus k is cancelled. That is, x minus k divides in evenly. So x minus k is a factor, which is what we're trying to prove. X minus k divides in evenly, because these will all cancel, and that tells us that x minus k is a factor, as long as, of course, k is a root, as long as fk here is equal to 0. So that's the proof.